In the diagram MNPQ, MNPQ is a circle with center 0. Line MN is equals to line NP, and angle OMN, is equals to 50. Find angle MNP, that's this angle, and II angle POQ, that is this angle. Okay, so before we begin, let's have a few facts. Let's look at the diagram very carefully and extract whatever information we can. First, this means that this line is equal to this line. That means this is an isosceles triangle, which means this angle here, this little angle here, is equal to this angle. Is that okay? That means if I know this little angle, I automatically know this too, and that makes it very easy for me to find my answer, MNP. Is that okay? Because these are base angles of an isosceles triangle. They are always equal. I can sum these three now and get 180, subtract to get my angle. Is that okay? So that's that. But before then, look at something else. This is a radius. That means is also equal to this, because this is also a radius. Remember, they say center 0. So this is equal to this. So this line here is equal to this line. Make OMP an isosceles triangle. Means if I know this, I also know this. Okay? And also look at this. This is a radius. This is also a radius. That means this is equal to this, which means this is an isosceles triangle again. If I know this angle, I also know this angle, and then I can find my second answer. You see? So that is just that about this question. It's very easy. Okay? So let's begin by seeing how we can utilize this angle. OMN, that is 50. Now there is a circle theorem that says that opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to give 180. That means you should know all your circle theorems. Is that okay? So let's look at that. This is equals to the opposite of the cyclic quadrilateral. Now, don't make mistake and think that this is your cyclic quadrilateral. No. Okay? This is not your cyclic quadrilateral, because this has not touched the circumference. A cyclic quadrilateral is just like a quadrilateral that you know, is a four-sided figure. But all the four vertices must touch the circumference. So this is your cyclic quadrilateral. Please be very careful. Students have made that mistake. So it means that this angle, if added to 50, is going to give me 180 degrees. Okay? They are supplementary. So that's where we are going to begin our work, so that we can get this angle. Look at this. And once I have this angle, there's another theorem that says that the angle subtended by a diameter. This is a diameter. Okay? Because it's passing through the center 0, it's a diameter. The angle subtended at the circumference by a diameter is 90. Meaning this entire place is 90. If I get this entire place as 90, and then I'm solving to know this place through using supplementary angles, it means I can know this entire place and I know this 90. If I subtract 90 from this entire place, I'll be left with this. That's how I'm going to get my answer. Is that okay? I'm going to repeat that. This is 90. Angle subtended by a diameter is 90. That is 90. And this entire place, I can get it. I'm going to get it right now. How? 50 plus this entire place is 180. And then I subtract to get this entire place. And this entire place minus 90 will be my answer. I'll be left with this place. So let's begin. So angle OMN, if I add that to angle NPQ, that is this entire angle, I should have 180. Angle NPQ, I should have 180 degrees. Why? Okay, now remember I'm trying to find this angle. Okay, but this place is what? This is 50 degrees plus angle NPQ is equals to 180 degrees. Then angle NPQ is going to give me 180 degrees minus 50 degrees, which is equals to 130 degrees. So this entire place is 130 degrees. Isn't that easy? Now, from what I stated earlier, angle MPQ is 90 degrees. So let's write it down. But angle MPQ is equal to 90 degrees. Why? Angle subtended by diameter. Okay, so we've gotten that. Now, what am I trying to do? I'm trying to do this entire angle, take away my 90. Okay, therefore I'm going to do angle MPN should be equal to what? This big angle, that is angle NPQ minus this one we just said is 90, angle MPQ. Don't let it confuse you. This one is NPQ, the big angle. We are subtracting MPQ, the 90 degrees. So that becomes, our big angle is what? 130 degrees. Subtract 90 from it, and that gives you what? 40 degrees. This angle here is 40 degrees. Okay? This angle is 40 degrees. MPN is 40 degrees. We said earlier that this is an isosceles triangle. That means this place here is what? 40 degrees. Let's write it down. Therefore, angle NMP, yeah, call it MMP, will be equal to what? 40 degrees. Why? Base angles of an isosceles triangle. Remember, we were told that this is equal to this. They gave us that fact. Okay, so let's proceed to finding this angle now. I know two angles, so I can easily find the third, right? Okay, so we've transferred the annotations down here. So we proceed. That means 40 plus 40, 80 degrees plus angle MNP is equal to 180 degrees. Therefore, angle MNP is equal to 180 degrees minus 80 degrees, which is what? 100 degrees. So we've gotten our angle MNP. That is I. Now let's go over to II. II says we should find angle POQ. Where is POQ? Angle POQ. So this tiny angle is what we are looking for. And like I said earlier, this is a radius, this is a radius. That means if I know this tiny angle, I can know this tiny angle as well. And when I do that, I add them, the same process to get this angle. Is that okay? Is that simple? Now, how do we find this tiny angle? Now let's look at it. I know this place to be 90, right? It means if I know this place, I can subtract it from 90 to get this place, right? Now, what can help me know this place? Do I know this entire place for me to subtract 40? No, I don't know this entire place. I knew this entire place to be 130. That was a place that was opposite to this. They had to be supplementary. is this entire place. It wasn't this place. So if I knew this place, I would subtract 40 to get here, but I don't. Can I know this place from somewhere else? Yes, I can know it from here. Look at this. We are told that this entire angle OMN is 50 degrees. But I've now discovered that this is 40. So it means this 50 minus 40 will give me this place. Is that okay? And that is 10 degrees. Okay? So I call that little angle OMP. So angle OMP will be equals to this entire angle, which is OMN, minus this place PMN. Angle, let's add an angle there, PMN. Is that okay? So that becomes 50 degrees minus 40 degrees, right? So that becomes 10 degrees. We've gotten this tiny place as 10 degrees, this place 10 degrees. So that means this other place is also 10. Why? Base angles of an isosceles triangle. Therefore, I can say that angle OPM is equals to 10 degrees. Why? Base angles of an isosceles triangle. Okay, so this is our 10 degrees. Now, if this is 10 degrees, remember this is 90. So we said but angle MPQ is equals to 90, right? Therefore, we have from triangle MPQ 90 minus this tiny angle here, we call it angle OMP. Is that okay? Will give us this angle, which is OPQ. I hope you understand. So 90 minus 10 degrees is equals to angle OPQ. That's 80 degrees is equals to angle OPQ. Therefore, angle OPQ is equals to 80 degrees. So we have this place as 80 degrees. Therefore, this angle OQP is also equals to what? 80. Why? Base angles of an isosceles triangles, they are always equal. So we have this as 80 as well. Therefore, POQ, if I add that to 80 degrees plus 80 degrees, I'm going to have 180 degrees, right? That is sum of angles in triangle POQ. Okay, so now let's go ahead and solve that. Angle POQ plus 80 plus 80, 160 is equals to 180 degrees. Angle POQ will be equals to 180 minus 160 degrees, and that is what? 20 degrees. Therefore, our triangle angle POQ is equals to 20 degrees, and that is our I. I hope you understand. Please kindly hit the like button and subscribe to our page to encourage us if you like our video. Until I see you in our next video, thank you. Bye bye.